Why, hello there again, Algebra 1 students. Mr. Cockbrenner going over the OST 2019 release questions. This would be number 4. So here we go. An incomplete table of values for an exponential function is shown. The exponential function is of the form y equals a times b to the x power, where a is a real number such that a can never equal 0, and b is a positive real number not equal to 1. Complete the table with possible values for the exponential function. So the only thing I don't like about this state test is they don't tell you exactly what this is. However, if we only had some notes. Oh my gosh, there it is right there, huh? So exponential functions. So this A is your y-intercept. We all know what the y-intercept, that's where it touches the y-axis. That is our initial value. So right here, it's 0, A in our notes. If you notice, that's the point that they give us. 0, A. So 96 is our initial amount. So after we input 1, what is our growth going to be? So we could do double, we can cut it in half. They're telling you to make b whatever real positive number you want to. So I think the easiest thing to do is just cut things in half, right? We have like the half-life formula technically for this. So what we're going to do is make this, let me get this out of the way for a second, y equals 96, because that's our initial value. Our a value says right here 0 comma 96, which is our y-intercept. And then let's just cut it in half. All right, what does it mean to cut something in half? Is just to make it 0.5. So with that being said, what is 96 times 0.5 to the x power? And that x power we're going to now say is what? Is what? We're making a table, so we're going to put 1 right here. So real quick, let's go to our old work there, and let's type in y equals 96, parenthesis, 0.5, which means we're going to cut it in half, and let's go to the first power. And we get 48. So underneath here, we're going to write our value of 48. And then all we're going to do for the next input is change this 1 to a 2. So we're going to do this twice now. And now that value is 24. So our output is 24. And last but not least, they want us to go to the third input value. So we type that bad boy into Desmos, and we get 12. And again, we call this the half-life because we're cutting the remaining amount in half. So we cut 96 in half, and we got 48. We cut 48 in half and got 24, and then cut 24 in half and got 12. We could change this to a 2 and double all these values. Our numbers are just going to get larger, okay? So if you wanted to change this out, this is a complete answer. So I would just type in this table here with my 48, 24, and 12 and call it a day. However, just to show you that we can do a little bit more, if we type in, this would be doubling it, right? So we would just say, hey, take 2 times that. So I'm going to go to Desmos and just show you how our answer is going to get larger here instead of smaller. Make that a 2 and go here to the first power. And that's 96 doubled is 192. Second input, we're at 384. And then the third input would be at 798. So this is definitely growing at a rate that we call doubling. All right, I just cut my numbers in half to make them smaller. And that is what this blue equation got us versus the green one. I hope that makes sense. All right, thank you very much.